Hello my precious friends and welcome to our today's class. It is our 11th and last lesson on the 5th topic of Form 3 work, which is called Current Electricity 2. As usual, let me commence by giving you the quote of the day, which states that the easiest way of accomplishing your dreams is by suffocating all your excuses. We shall discuss that quote at the end of our class today. So we are looking at further examples involving the formulas that we have just derived in our previous class, that is for the EMF. So the first question reads that a battery consisting of 4 cells in series, each of EMF 2 volts and internal resistance of 0.6 ohm, is used to pass a current of 1.6, that is a current through a 1.6 ohm resistor. So calculate the current through the battery, So immediately you see the word internal resistance. It simply means that we are using the formula involving internal resistors. Then we know that for any for EMF is given by the current into the external resistor plus the internal resistance. So these are just the formulas that we have derived from our previous lesson. Then also these equations still hold that for any series connection, these equations must be obeyed, and for any parallel connection, these equations must be obeyed. So because in this question we are told that a battery consisting of 4 cells in series, so that means we are going to consider the equations for series connection. So they want us to calculate the current through the battery. So they want the current I. So for you to find the current, you must have the EMF, you must have the external resistance, and also the total internal resistance. So our first task is to find the EMF of that particular cell, that is the total voltage through that particular circuit. So we are told that a battery consisting of 4 cells in series, each of EMF 2 volts. So because they are connected in series, and we know that for any series connection, V total must be equal to V1 plus V2 plus V3, depending with the number of cells that are in that particular that are constituting that battery. So for series connection, V total must be equal to V1, V2, V3, and so on and so forth. So because we are told that it consists of 4 cells in series and one cell has a voltage of 2 volts, it means that the EMF, or the total voltage, which is the V total, or the EMF through that particular battery, which is consisting of 4 cells, will simply be given by the voltage drop across the first resistor, across the first cell, plus voltage across the second cell, plus voltage across the third cell, plus voltage across the fourth cell. So adding the voltages because we are told that they are in series connection, and for series connection, V total, you simply add the sum of the voltages. Therefore, the EMF through that particular battery will be the voltage through the first cell plus the second plus the third plus the fourth. And we are told that each cell has an EMF of 2 volts. Therefore, the EMF for the 4 cells within that particular battery will simply be 2 plus 2 plus 2 plus 2 volts, which will give us a total of 8 volts. Then from there, again, from this formula, we need the total internal resistance, that is small r. So again, we are told that they are in series connection. And we know that for any series connection, R total must be equal to the sum of the resistances. That is, R total must be equal to R1 plus R2 plus R3. So because we are talking of 4 cells, and we know that each cell has its own internal resistance, and we are told that an internal resistance of 0.6 ohms. So this is the internal resistance for one of the cells within that particular battery. And because there are 4 cells and they are connected in series, the batteries are connected in series, then the total internal resistance, R total, must be equal to R1 plus R2 plus R3, because we are talking of series connection. So the total internal resistance, R total, will simply be the sum of the resistances across each, that is internal resistances across each cell. So that will be R1 plus R2 plus R3 plus R4, because we are told that there are 4 cells and each has an internal resistance of 0.6. Therefore, the total internal resistance will be given by 0.6 plus 0.6 plus 0.6 plus 0.6, which gives us a total of 2.4 ohm. Then, once we have the EMF and the total internal resistance, and remember we are also given the external resistance, we can easily compute the current that the question demands from us. So the aim here is just to ensure that you have all the values. So ensure that you have the EMF, you have the external resistance, and you also have the total internal resistance. So from the equations that we looked at from our previous class, that is the equations for the EMF, we did say that EMF can be given by the total current into R plus R. Of course, where R is the resistance of the external resistor and small r is the resistance of the internal resistors. Therefore, because they want us to calculate the current through the battery, we'll simply make current to be the subject of the formula. That is by dividing both sides by R plus small r. Therefore, if I make current subject of the formula, which is I in this particular case, I'll have current being equal to the EMF E divided by R plus small r. That is, R is the resistance through the external resistor, and small r is the resistance, that is the total internal resistance through that particular battery. So the EMF, we have found that the EMF of the battery is 8 volts. So 8 volts divided by the resistance of the external resistor. We are told that EMF of 2 volts and internal resistance of 0.6 is passed to a current through a 1.6 ohm resistor. So this is the external resistor, or the resistance of the external resistor, which is noted by capital R. So R is 1.6 plus the resistance, the total resistance, the total internal resistance, we have computed it as 2.4 ohms. So plus 2.4 ohm. So this will give us 8 divided by 1.6 plus 2.4, you just get 4. So 8 divided by 4, you'll get a total current through that particular battery, a total current of 2 amperes, the current of 2 amperes. So the most important thing to note is this particular formula. So for any question involving internal resistance, this equation for the EMF must be obeyed. And we said that this equation can also be represented in other formats. For example, when you open the bracket, you will have IR plus IR. Yeah. Then question 2 reads that a battery of 2 identical cells, identical means that they have the same properties, that is, their internal resistance is the same, and also the voltage through each cell is actually the same, or the EMF through the cells are the same. So they are identical, or they are the same. Each of EMF 1.5 volts and internal resistance of 0.6 ohms. So they are connected in parallel, and we are required to calculate the current the battery drives through the 0.7 ohm resistor. So again, we must obey this equation. So because they are talking of internal resistance, therefore the equation for the EMF must be obeyed. So our aim is to find the total EMF. We also find the resistance of the external resistor and the total internal resistance. Then from there we'll be in a position to compute the total current, or the current through the 0.7 ohm resistor. So because we are told that there are 2 identical cells and each cell has an EMF of 1.5 volts, we just sketch our diagram. So we have the 2 cells which are in parallel to each other. So parallel, that is the parallel connection. So that means for this case, we shall consider this particular rules or the equations for parallel connection. So the first thing that we need is the E, or the EMF. And remember, the EMF simply represents the total voltage. So because we are talking of connection in parallel, it means for any parallel connection, V total must be equal to V1 must be equal to V2. And remember, the V total is just the EMF, the electromotive force. Therefore, that means that for any parallel connection, the EMF is equal to the voltage across each cell. Therefore, we shall say that because they are in parallel connection, the EMF, or the V total, must be equal to the voltage through the 0.6 ohm resistor must also be equal to the voltage, that is the voltage through the 0.7 ohm resistor. That is, the voltage is actually the same for the parallel connection of resistors. So because the battery has 2 identical cells, then it is connected in parallel. So therefore we shall say that E, or the EMF, or the V total, must be equal to the voltage across each cell, which is the 1.5 volts. Therefore, the EMF of the cell is 1.5 volts. Then the other thing that we need to find is the total internal resistance. And we are told that there are 2 identical cells. So because there are 2 identical cells, then we are talking of parallel connection. We know that for any parallel connection, 1 over R total must be equal to 1 over R1 plus 1 over R2, and so on and so forth. So because we have only 2 identical cells, it means the internal resistance of those particular cells will simply be R1 and R2. Therefore, if we want to find the total internal resistance for parallel connection, then 1 over R total, because we are talking of they are connected in parallel, so we use the equation for the parallel connection. So 1 over R total must be equal to 1 over resistance through the internal resistance through the 0.6 ohm resistor plus the 1 over R through the 0.6 ohm resistor. Remember, these are just, we are told there are two identical cells. That's why we only have 1 over R through 0.6 and 1 over R through 0.6. If there were maybe 3, we could have added plus 1 over R through 0.6. But because there are only 2, we just have two equation or two values representing our formula. Therefore, 1 over R total, and remember small r represents the total internal resistance. 1 over R total will be equal to 1 over 0.6, which is the resistance through one of the resistors. So we are told that each has an internal resistance of 0.6 plus 1 over 0.6. So of course 1 over 0.6 plus 1 over 0.6, you'll obtain 10 over 3. So 1 over R total is equal to 10 over 3. If I take reciprocals on both sides, I'll simply have R total being equal to 3 over 10. Therefore, the total internal resistance through the battery is actually 0.3 ohm. That is 3 divided by 10, we get 0.3 ohm. Then from the equation of the EMF, that E must be equal to I into R plus small r. Remember, our aim is to find the current, so we just substitute the values that we have. So the EMF through the battery is actually 1.5 volts, because remember, for any parallel connection, V total is just equal to the voltage across each cell. Therefore, the EMF, if I want to find the current, I'll make the current to be the subject of the formula. That is by dividing both sides by R plus R. So the current will be equal to the EMF divided by the resistance through the external resistor plus the total internal resistance. So which is equals to the EMF of the cell is actually 1.5 volts. That is the 1.5 volts divided by resistance through the external resistor. We are told that it was connected. Calculate the current the battery drives through the 0.7 ohm resistor. So this is our external resistor, that is the 0.7 ohm resistor, plus the small r represents the total internal resistance, which is actually 0.3. So that we have 1.5 divided by 0.3 plus 0.7, you'll just obtain 1. So 1.5 divided by 1, you'll obtain a total current of 1.5 amperes. Next, we look at our last example, which reads that a cell drives a current of 2.0 amperes through a 0.6 ohm resistor. So when the same cell is connected to a 0.9 ohm resistor, the current through, that is the current that flows, is 1.5 amperes. So find the internal resistance and the EMF of the cell. So of course, the formulas that connect the internal resistance and the EMF is just the formula, that is the EMF is equals to IR plus I small r. That is, the EMF is equals to the product of the total current times the external resistance plus the total current times the internal resistance through that particular cell. So because they want us to find the internal resistance and the EMF, we'll start by giving them letters. So we shall say, let the internal resistance be small r and let the EMF of the cell be represented by capital E. So from the formula of EMF, that EMF is equals to IR plus IR. So we are told that it is actually the same cell, meaning that the EMF through that particular cell is the same, and also the internal resistance through that particular cell is the same. That's why they are talking of the same cell. It means the EMF for the first case is the same as the EMF for the second case. The total internal resistance for the first case is also equal to the total internal resistance for the second case. So let's just substitute the values that we have. So we are told that a cell drives a current of 2 amperes through a 0.6 ohm resistor. So remember, the 0.6 ohm is the external resistance and the 2 amperes is the total current. So we shall say the EMF E is equals to the total current through the circuit for the first case is 2 amperes times the external resistance is actually 0.6 ohm. So times 0.6 plus the current, the total current through the circuit is 2 amperes times the external, that is the internal resistance is R, because we are not given in the first case. So this will give us the EMF being equal to, of course, 2 times 0.6, you'll obtain 1.2. So the EMF is equals to 1.2 plus 2R. So that forms our first equation. Then we are told that the same cell, so the same cell means the EMF in the first case is the same as the EMF in the second case. Also, the internal resistance in the first case is equals to the internal resistance in the second case. So we also substitute the values for the second case. Again, EMF is equals to IR plus IR, of course, where small r is the internal resistance. So we are told that when the same cell is connected to a 0.9 ohm resistor, now when the external resistor becomes 0.9, the current, that is the current that flows, is 1.5 amperes. So for this case, the EMF, we don't have the EMF, the current that flows is 1.5 amperes, so I just substitute the current is 1.5 amperes multiplied by the external resistance is 0.9 ohm, so times 0.9 plus the total current is 1.5 amperes times the internal resistance is simply R. So this is equals to EMF E is equals to 1.5 times 0.9, you'll obtain 1.35 plus 1.5 times R, you'll just obtain 1.5 R. So this forms our second equation. So because they are using the same cell, the value of the EMF for the first case is equal to the EMF for the second case. Also, the internal resistance for the first case is equals to the internal resistance for the second case, because they are talking of the same cell. Remember, the same cell will have the same EMF, they will also have the same internal resistance. So because E, that is E and R, are the same for the first case and for the second case, it simply means that we are dealing with simultaneous equations. And we know that from mathematics, we have a variety of ways in which you can solve simultaneous equations. One, you can use the graphical method, you can use the matrix method, you can use substitution method, you can also use elimination method, that is from mathematics. But I think the easier one for this case, I'll just use elimination method. So I want to solve my equation 1 and equation 2 by elimination method. So let me just rewrite the second equation. So I'll have the EMF E being equal to 1.35 plus 1.5 R. Then I also rewrite the first equation, which was EMF is equals to 1.2, so 1.2 plus 2R, so plus 2R. So if I want to eliminate the EMF E, because we have E, we also have E down here. So if I subtract the two equations, actually I'll eliminate E, so I'll eliminate one of the values. So subtracting equation 1 from equation 2, I'll have the following. E minus E, I'll just obtain 0. Then 1.35 minus 1.2, I'll obtain 0.15. Then 1.5R minus 2R, I'll obtain negative 0.5R. Then I want to take negative 0.5R towards the left-hand side so that it becomes a positive. So I'll have positive 0.5R being equal to, on this other side I've remained with 0.15, so it's equals to 0.15. If I want the value of R, I'll just divide both sides by 0.5. So R is equals to 0.15 divided by 0.5, which gives me 0.3 ohm. Then substituting the value of R in the first equation so that I solve for the value of the EMF E, I'll have the following. So remember, the first equation was EMF E is equals to 1.2 plus 2R. So I just substitute the value of R in this equation here so that I'll have the EMF E being equal to 1.2 plus 2R. But my R from up here is 0.3. So this will simply be 1.2 plus 2 times 0.3, I'll obtain 0.6. Then 1.2 plus 0.6, I'll obtain an EMF of 1.8 volts. Therefore, the internal resistance through that battery is 0.3 ohm. Then the EMF through that particular cell was 1.8 volts. Then I have an exercise here which I recommend that you should try at your own free time to gauge your understanding. Of course, if you have any challenges in solving any of the questions, feel free to drop a comment specifying the questions that you need help in. So this is our first question on the exercise. We also have more questions on the exercise here, so try them and see whether you get answers which are similar to mine. And of course, if you have any challenges, just specify through the comment section, and of course I'm always there to help where possible. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that the easiest way of accomplishing your dreams is by suffocating all your excuses. So the quote is warning us about the negative impact of excuses in our life. Remember that finding excuses is one of the most common ways used by people whenever they are afraid of pursuing their dreams or whenever they are afraid of doing something. So I'm here to encourage you to overcome the fear of your present circumstances. Yeah. Never allow yourself to be defined by your present circumstances. Yeah. You can be more, you can do better by just working hard. And lastly, recall that the easiest way of overcoming your excuses is by taking action. That is, do what you can where you are using the resources that you have today. So thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. If you know any student that you honestly think could benefit from this content, kindly share my link to them. This is Kind Tuition Academy. Until next time.